Welcome to Chapter 1. As you can see, Chapter 1 has to do with defining and collecting data. Again, this is fundamental material that you will use throughout the course. It's not necessarily a lot of math in this particular chapter, but it's an introduction to some of the terminology, some of the processes that we use. So in this chapter, we're going to talk about what variables are, how to define them, how to collect data, how to understand what the issues are, how to prevent some surveying errors. So you have categorical variables, such as yes, no, things like colors. It could also be things like dent, scratch, chip, things along this line. And then, of course, you have quantitative or numerical variables that the discrete ones are counting. So 1, 2, 3, 4, 5. Continuous are things like, say, measuring liquid. So it goes from 1 to 1.01 to 1.02. They can even have more decimal places, but it's a continuous. Discrete would have gaps between the numbers. Continuous does not. So here's some examples. Do you have a Facebook profile? Either you do or you don't. So that's categorical. How many text messages have received in the last 3 days? How long did the mobile app take to update? You can quantify those in the sense of there's a number. It took 3.7 minutes to update my app. So you can see here's some of the providers for the cell phones, the type of investment, growth, value, or other. So that would be categorical, and they don't, as you can see, there's no numbers, there's words. And the nominal scale simply has to do with there's no ranking as far as like for type of investment. Growth isn't twice as large as value. There's no sort of ratio. It's just growth, value, and other, or red, white, and blue. So again, here's some more examples where there's an ordinal scale, where if you are a freshman or sophomore or junior or senior, most of you in this course are probably either sophomores or juniors from my experience in teaching stats before. Maybe there's even a few people who are in your fourth year, which would be a senior. So you can see all the different types of categories, bond ratings, your student grades, and you have A pluses and A's and A minuses and all of that. So those are categories. They're not a number. You're not given a number, but you are given like a letter grade. So what really matters at the end of the term is not your mark. Your mark determines your letter grade. So somebody, there are some schools who, let's say somebody got a 75 and then somebody got a 76. They just record 75 and 76. That's it. They give you your percentage. And other schools will be, that's for a lot of schools, that's a B, whether it's a 75 or a 76. All right. The interval scale is an ordered scale in which the difference between the measurements is meaningful. And we'll look at an example. The ratio scale is, it also has a meaningful quantity and have a true 0 point. So we're going to look at a couple of examples. So temperature, either in Celsius or Fahrenheit, there is no 0. Like, well, there is a 0, but you can go below 0 and above 0. Standardized tests like the SAT, your height starts at 0. Okay, you can't have a negative height, you can't have a negative weight. You can lose weight, but you can't have a negative weight. Your age starts at 0 and goes to whatever age you are. And then you say your salary in Canadian dollars. We wish we got paid in US dollars, but at this point we get paid in Canadian dollars. So here's just a breakdown for you. There's going to be a little bit on your first assignment just to give you a feel for this. It's not it's important to understand the differences, but it's not usually something that comes up that often, that whether, ooh, is that nominal or is that ordinal? Like that's really for people who get into, you know, high level statistics. They understand that. And it's just, how should we record the information? Usually it's fairly self-explanatory. Like if you're going to record something you want to, for time, that would be numerical. And time, depending on how you record it, could be continuous. So, you know, you have on your smartphones, you have the ability to have a stopwatch, and you can wind up that took, you know, 3 minutes, 17.2 seconds. So population is discrete, and a population contains all the items. So all the people, the population of Calgary, the population of Alberta, the population of Canada, the population of the world, things along this line. And a sample is a subset. So if you defined the population of as the city of Calgary, you can't take a sample that includes places like Okotoks or Airdrie or Cochrane. What you would need to do is select areas from Calgary, from the 4 quadrants of Calgary. So, you know, northwest, southwest, northeast, and southeast. So, but it has to be from Calgary. Can't be Bicyker. So you can see here, the sample is smaller, is less than by at least 1. So it's like n minus 1 compared to the sample size. The sample size is 1 less than the population size, or it can be more, but it has to be, if it's the same size, then it is the population. So in the sample can be 39, anywhere from 1 to 39, but it's drawn from the population. Sampling is less time consuming. Also, that means it's less money. And just think about, okay, I'm going to give you an assignment. I want you to count the population of Canada. By the time you get to the end, if you lined everybody up, then some of the people that you've already counted will have left Canada, and there'll be new people coming in. There'll be births, and there'll be people who pass away. So and it would be a very time-consuming process. So you take a sample. Statistics is heavily, heavily reliant on sampling and inferential statistics. We take a sample, and then you say, I'm fairly confident, and we'll determine what that fairly means, that this is what the population looks like. So you take a sample of drivers to find out what the driving statistic looks like for, say, distracted driving. What percentage of drivers are talking on their cell phones? And of course, that has gone up over the years but then it's also perhaps gone down because we now have a lot of cars that are capable of having audio or Bluetooth within their cars, so they can talk on the phone, but they're both hands are still on the steering wheel. At least we hope so. Anyways, all right. Again, some of these terms, population parameter would be like the average age of person in Canada is 47. But if it's from a sample, it's called a statistic. All right. So just a slight difference between the two. And I might ask you a question here or there on that, but it's not going to be a major point. Which almost in this course, we're going to deal almost exclusively with samples. So we're going to be dealing with statistics. So surveying, asking people what kind of laundry detergent they use, political polls come out all the time. You know, they'll recently they were having, like, when they were talking about building a new, I guess, event center, replacing the Saddledome, there would have been like, what percentage of the population supported that? What percentage didn't care? or weren't sure, and then what percentage were against the idea. So you can use it for marketing. So if anybody's a marketing student, you're going to use this a lot. You can have focus groups. You can also have measurements, and companies set standards, like in fast food, how long it takes to make the particular item, how many, even what percentage of error they're allowed. I know that the Walmart logistics, if I remember correctly, is allowed something like 0.8% damage. No, $80 per million, whatever percentage that works out. That's the number. They're allowed $80 of damage per million. And that's the standard that they set. There's going to be a certain amount of waste. There's going to be damage. That's just a reality. But measuring that. So then you have primary sources of information where you talk to, say, the people directly. And then you have secondary sources. And having finance as a background, all the research in finance, or almost all the research in finance, is from secondary sources. Like you get the information from what is the price of a stock, what is the price of a warrant or a right, and things along this line. So that's based on secondary sources. You don't talk to the people who bought and sold the stock. All right. So you need to be careful how you frame your sample. Are we going to survey all the Mount Royal students? Are we only going to survey the business students? Are we only going to survey the female students? Are we only going to survey the students who are above 6 feet tall? Are we going to survey the students who have blue eyes? Like, you have to be careful how you define your students, because you're going to get a different type of response or different answers if you're talking to the business students. Recently, I had an opportunity to teach some students in the communications area, and there was two groups. There was the public relations students, and there was the information design. Oh, they were very different than any other business student I've taught at Mount Royal. And they're different than any student I taught at SAIT, and I've also taught at University of Calgary and University of Lethbridge, and they were different. I'm not saying they were better, I'm not saying they were worse, but they were different, and you get a different response from that. For example, the public relations students had a class of about 30, 28 females and 2 guys, if I remember correctly. The information design was very close to 50-50. So you're just going to get different responses based on that and their interests. So again, don't spend a huge amount of time on this. Just pay a little bit of attention to it, to be honest with you. So that survey that I mentioned earlier about just surveying the students who were walking down the hallways at your school, that would be a survey of convenience. What you really want is you would like a simple random sample. We'll go through this. Convenience samples are based on that they're easy, they're inexpensive. So convenience sample, you do this whether you realize it or not. You talk to your friends. So what do you think about what's happened with the pandemic? How is that affecting you? You've talked to friends and family, but that's because you can. Have you talked to everybody? Have you talked to some students I know are struggling immensely. Some faculty are struggling immensely with the pandemic situation. Some people are okay with it, and then some people are loving it from the fact that they don't have to get on their bus and get up that early. They can listen to these recordings whenever you want. This is like Netflix. This is on demand. And there's a lot of things like this that I'm going over right now that I have said for years, we don't need to be in the classroom to do this. You'll see that we'll have live lectures. There will also be pre-done examples, but this doesn't really lose much because Not a lot of interaction goes along when I'm lecturing, all right? Judgment sample, you talk to experts. Those of you who are into sports, you're like the insider, the people who pay a lot of attention to this, people who are financial analysts for the stock market, et cetera, et cetera. Supposedly, they have a better understanding of what's going on and the trends and the nuances of what's going on, but sometimes they are rather clueless. So you've got probability samples where you're taking a certain percentage, and we're actually going to later in the course determine exactly how many we need to select. All right, simple random sample. The biggest thing with this is every observation, every data point that you get has within the population, each has an equal. Even if we're to stand in front of a class and look around and select 4 students, it might appear at random. I might not even realize that I have a bias. I might pick people that look like me. I might pick more men than women or more women than men. I might pick people who have brown hair for whatever reason and not even realize I'm doing it. But if you had, say, 30 students in a class and you have a random number generator, like we'll use in Excel, then everybody has an equal chance. It's blind. If I closed my eyes and assigned, the numbers 1 to 30, even that might not work because I have favorite numbers. Probably a lot of you do too. All right, and we'll do some assignment questions where there's a with replacement, where you select an item and you put it back in. And then there's other ones where you select the item, say number 3 out of the 30, and you don't put it back in. So those people who play the lottery, that is selection without replacement, because you can't have 3 in a Lotto 649 draw or Lotto Max. You can't have 3 selected twice. There's 6 or 7 numbers, and they're all selected once with no duplicates. All right, and we'll do some on this. So, and we'll do this is a lot of this is a basic core information about statistics, and you can see the first 5 items are selected at random, and there is no 892, but there is a 492 and an 808, etc., from our random number table. Okay. Now, you determine the sample size. Later on, we'll get more sophisticated with that. There's actually mathematical formulas to determine the sample size. And what this does is, and even when I set up your study plans that I'm going to, that you're going to use in this course, should you want for practice, I can tell it to pick every 3rd question. But what I did is I told it to pick all the questions that are on assignments or quizzes. So if you see it in the study plan, then you're going to get it on your assignment or your quiz. And if it's not on the study plan, it's not on the assignment or the quiz. So it's filtered for you. So those study plans, those study guides, which I'll go over during my introduction to the course, are very valuable. 85%, we did a survey, 85% of students regularly or always use those for studying purposes. So there's your first step in how to succeed in this course. All right, stratified, divide the population into 2 or more subgroups. Sample is selected from each subgroup, a random sample, and then they don't have to be the same size, and then you compare the proportions. So let's say you did a sample of one group is 10 and the other 7, and then you'd have 3 and 2. You divide that and turn it into percentages. And you can combine the subgroups if you want to get overall, but it allows you to bring 2 subgroups together. Clustering, all right? In this case, you can see you break the group into clusters, and then select randomly from the clusters. So in this case, you divide it into 16 clusters, and you randomly pick, in this case, 3 of them. The 4th one, the 6th one, and I believe that's the 11th one from the left. So you want to keep your sampling simple, and you want to keep it, the best one is a simple random sample. And that's good if you want sort of like an overview type of thing. But if you are only interested, if your target for that radio station is a younger demographic, say the people in their 20s, then yeah, you would want to know what kind of, you don't care about the people who are in their 40s or 50s. Those are just extra. Or or radio stations that target certain types of listener. And so you want to know what the young people are listening to, and you want to know if they are actually listening to your radio station. So, going around and surveying students at the school is not necessarily a bad idea. Cleaning data. This is data that got recorded incorrectly, is missing, there's typos in it. Let's say all the numbers are supposed to be from 1 to 10. And somebody types in 70 rather than 7.0. You remove that. You take that out. You might assume that it's 7.0, but maybe it's 0.7. You can't just make stuff up or modify it. So you need to remove things like that. We'll also deal with items that are called outliers in an upcoming chapter, where we say that's a really large number. What if all the numbers were between 1 and 10, and then I had one number that was 983? You look at that and say, that doesn't seem right. What's wrong with it? We can mathematically or statistically prove that that is what's called an extreme outlier in that case, and that we can remove it from the data and then recalculate things like the average, etc. And then you're also looking for being careful about redundant columns and duplicated rows and things along this line. So making sure your data is clean, that your data has been properly filtered. As the saying goes, you've probably heard the saying, GIGO, garbage in, garbage out. So you need to spend time and effort making sure that your data is good. Now, fortunately for you, your data in the data sets that come with the book have been cleaned, but in industry, they're not. So you might get information from 2 sources, but there's one part of that is doubled up. So that's going to distort your data. All right. All right. You can simply look at the data, just check it over with your eyes. You can set parameters, an if statement that if it's above a certain value or below a certain value. So you're looking for what are called, again, outliers. And we'll do that in a more sophisticated way in an upcoming chapter. So, gender these days is not just male or female. There's also, transgender, or do not identify as a certain gender. Like there's, what used to be on like driver's license, you could look as male or female. Well, now these days there's even, do not wish to declare, or things along this line. So you can, in this particular case, their example is that they put in the state of New York, okay, and for whether it's gender, okay. So female is fine. New York is fine. You also have to be careful whether, you can see that they've got capital F and capital M. You have to be careful with that. Years ago, when we started doing data collection, secretaries, which is what they used to be called, or admin assistants as they're called now, on a typewriter, if you even know what that is, they would hit the L key instead of the 1 because they look the same. lowercase l and a 1 would look the same, but the computer doesn't treat them the same. An L and a 1 are different, even though they might look the same. Just like I'm sure at some point you've probably been perhaps frustrated. Is that a 0 or an O? So one is an alpha and one is a number. So, and again, so that's what we're talking about with correcting is it a lowercase m or capital M? Does it matter? Somebody might enter them as lowercase, if somebody has the cap locks on, fine. So these are just points of, if you want us, that you would need to be careful of if you're out there, when you're out there in industry collecting data, right? You have missing data, like why was this group not included, or did we even know that group existed? Excel, which we're going to focus on, as I mentioned before, so can help us with data cleaning. There are other programs like Tableau, Power BI, and other data analytics software. Your book shows Tableau. So if you really are a keener and you're really interested in pursuing, say, data analytics or business analytics, then you can actually play around with that. They've got some really good videos on this, and I've selected some videos for you for using Excel, and I'll create some of my own. Right. So formatting the data, making sure that it's, some cases it's ordered properly, that is it numbers, is it dollars, etc. Is it a percentage? All right. Now I'll let you go through and read this. This is just sort of how you record some of the data. It can be a supplement or replace the original value. So that lowercase m can be replaced by a capital M, so they're all consistent, and things along this line. So you still need to be careful of what's the purpose of the survey. Is the survey going to be on probability? What's the appropriate frame, including the time, right? What if there's no response? What if you say the students at Mount Royal when they graduate, or State when they graduate, or USC when they graduate, will get a follow-up? You know, what did you think of your education? Have you found a job in your field? Things along this line. There will be certain students who don't respond to that. Just in the same way that when you get buy something online, a lot of times these days you'll get a follow-up. How did we do? How did we do? How did we do? You know, at a certain point we perhaps get tired of them and we don't really care. Or even a student I don't want to fill out the online form for how the course went. I don't really have anything to say. I don't want to take up my time. So those people just don't respond. So, you know, some websites either tend to get people who either, like, say, really love something or really don't like something. All right. So coverage error exists. Some groups are excluded from the frame, have no chance of being selected, such as somebody who has pink eyes. Okay. Well, there's nobody with pink eyes that I'm aware. Okay. Not normally anyways. So we're excluding some group. You get my point. Okay. I didn't want to say a specific group because these days you have to be so careful about what you say. But anyways, just excluding some group for whatever reason. Be very careful about bias. If you have a favorite color, you have a bias. If you have a favorite number, you have a bias. If you have a certain, how should I put this? If you have a certain look that you like, say in a potential partner, that's a bias. And it's not saying it's right, I'm not saying it's wrong, but it's just something you need to realize. I'll give you one. There are some times where it goes both ways, where, say, females do not like to date males who are shorter than them. That's a bias. There would be, say, certain gender who likes the other gender to have blonde hair. whatever the case may be. Those are bias. Those are biased. They're not used to discriminate in a lot of ways, which is very negative. But anyways, so you get the idea. All right. So be careful about the bias, and also pay attention to, why didn't these people respond? Is it because they didn't like their experience at the school? Is it because they are, well, why? What you want to know? Just like I would like to know, like for the people who don't fill out the instructor evaluations and the course evaluations. First of all, why didn't you fill it out? And I understand some of the reasons, but I'll put in a plug already. I really want to hear what you have to say. Even after 20 plus years of teaching, I still want to do a better job and a better job and a better job. All right. So here's just a graphic on it, on what was on the previous slide. Ethical issues, again, lots of, especially surveys and things that were done years ago were, in some cases, unintentionally biased or towards a certain demographic. Remember an example, this is as basic as it might sound, but the purpose was, the survey had something to do with utensils, like forks, knives, and spoons. And this person was from a very poor country, did not know what a fork, a knife, or a spoon was. So does that make that person less intelligent? Or is there a bias in the survey? So you get the idea. All right. So here's our summary. Be careful when you're defining the variables. All right. Be careful about the different measurement types of scales. Be very careful how you collect the data. So spend a lot of time defining, and then how are we going to get the data? Are we just going to do it online? Then all of a sudden you're assuming that then you're only selecting from people who have internet. And now it might seem like everybody has internet, but no, not everybody has internet. Okay. And, there will be a certain type of person who uses the internet more. Are you more likely to get them to fill out the survey, and how you're going to collect the data? I remember years ago, like, doing phone surveys, which we've all had. Well, what if a person doesn't have a phone? Or what if a person has an unlisted number? Okay. So things along that line. So that's a bit of a summary of chapter number 1, and we'll do some examples from chapter number 1, and I hope you found this useful.